All right, we have this question, one of the assignments, question for mathematics, binary operation. A binary operation, symbolized as asterisk, is defined on the set of positive integers such that x by x operation y is equals to or is given by 2x minus 3y plus 2 for all positive integers x and y. The binary operation is, okay, so we have a set of options. Basically, we have to test for commutativity and closure. So we want to test for commutativity. Is the operation commutative on the set for positive integers? And is it closed? Is this operation closed on the set of positive integers? So the easiest approach is to test with numbers. So you look for the positive integers because that's the set we are testing for. Positive integers, set of positive integers. And those are numbers greater than 1, greater than 0, sorry, your normal counting number. So you just take a pair, for instance, 1 and 5. Let's test for closure. Testing for closure, basically you want to make sure that the result gotten from this is still a positive integer. So this is your rule. X operation y is given by this rule from the question, 2x minus 3y plus 2. So using 1 and 5, like I said, that's just the easiest approach. Use known numbers, okay, that are they have a gap between them, like 1 and 5. 1 is the smallest member of the positive integer set, okay. So, and 5 is a little bit away, okay. So 2, so your x replaced by 1 and y replaced by 5. So put it into the rule for the binary operation. 2 times 1 minus 3 times 5 plus 2. That's 2 times 1. That's minus 3 times 5. That's minus 15. Everything equals to minus 11. That minus 11 does not belong to the set of positive integers. So the operation asterisk is not closed on the set of positive integers. The operation is not closed on the set of positive integers because we have a result which is not part of the set of positive integers. Even though 1 and 5 are part of positive integers, the result of the operation on them is not operation on 1 and 5. The result, which is this minus 11, is not part of the set. So the set is not closed. The operation is not closed on the set of positive integers. Next up, we look at commutativity. This is basically the formula for commutativity. X operation y should equal to y operation x. Okay, for all x and y belonging to the set of positive integers. So when you swap the operands, that's x and y, it should still give you the same result. So let's choose, like we've chosen 1 and 5. 1 and 5 because they are positive integers, and 1 is the smallest positive integer. So these are ideal numbers, okay, to test, okay. So just try by error. So if x is 1 and y is 5, put it into the rule. These are the rule from the question, 2x minus 3y plus 2. So x is now 1 and y is 5. So that's, if you substitute that in, you have 2 times 1 is 2, minus 3 times 5 is minus 15, plus 2, you get minus 11. So now we also have to test for this alternate positions. So swapped positions now. Y is now the first operand, x is the second operand. We are still using 1 and 5. So y is 5 and x is 1. So y, which is 5, comes into this place, and x, which is 1, comes into this position. So 2 times 5 is 10, minus 3 times 1 is minus 3 plus 2. So it's just swapping position. The values of x and y which we are testing for, we are using 1 and 5 as test values. Okay, so you try by error. I decided to choose 1 and 5. Okay, you can choose 1 and 6 if you like, 1 and 7, but the gap should be there so that I think it's an ideal test numbers. So 2 times 5 is 10, minus 3 times 1 is minus 3 plus 2. You're going to get 7 plus 2, which is 9. So you observe that minus 11 is not equals to 9. That means x operation y is not equals to y operation x. Okay, so therefore the operation is not commutative on